Let me introduce to you another product of vectors, what we call vector cross product. So comparing that to the scalar dot product, the result of the dot product of two vectors is scalar. So it means the result is only magnitude. It has no direction. While a vector cross product, the product is a vector. Alright? So we denote the vector product of two vectors, vector A and vector B, also called the cross product, by vector A cross vector B. So we read this as vector A cross vector B. And the product is a vector. And the product vector, okay, the product vector is perpendicular to both vector A and vector B. Okay? The product vector of vector A and vector B is perpendicular. It means it forms angle between vector A and vector B. So suppose we have two given vectors here, vector A and vector B. And the angle between vector A and vector B is angle phi. And angle phi is measured from angle vector A to vector B. So we have, if we look for vector A cross vector B, then this is the product. The third vector is the product of two vectors. The third vector is perpendicular to both vector A and vector B. Alright? We can use right hand rule to find the direction of vector A and vector B. Okay. Suppose these are the two given vectors, vector A and vector B. There is angle between them, angle phi. Okay, this is the common point where the tail is placed. The tail of vector B and the tail of vector A is placed at the common point. The cross product of these two vectors is, let's say, we can represent the third vector with this marker. The product of these two vectors is perpendicular to both vector A and vector B. Alright? Vector A and vector B are at the same plane, lying on the same plane. So it means these two vectors are coplanar. Coplanar, it means they are lying at the same plane. And this vector must be perpendicular to the plane where these two vectors are lying. So we have vector A perpendicular to vector B as well as vector A. Right? So this is the cross product of these two vectors, perpendicular to vector A, vector B as well as vector B. The vector cross product is anti-commutative. Okay? Anti-commutative, it means, say anti-commutative, with this commutative property, if we have vector A cross vector B, that will be equal to vector B cross vector A, if that is commutative. But the cross product of two vectors is anti-commutative. So it means vector A cross vector B must be equal to the negative vector of B cross vector A. Okay? So again, we can use the right hand rule to determine the direction of the cross product of two vectors. So we will use the right hand rule. We will not going to use the left hand rule. So if this is the right hand rule, if this is vector A and this is vector B, right? So this is vector C. Vector C is perpendicular to vector A and vector B. Now, if we're going to look for vector B cross vector A, right? So this is vector B cross vector B cross vector A, which is negative. Okay, opposite direction to the vector A cross vector B. So again, if this is A, I will mark A, and this is vector B, and this is vector C. Alright, vector A cross vector B is vector C. Okay, let us represent the cross product of these two vectors as vector C. So it means vector C is perpendicular to vector A as well as vector B. But how about vector B cross vector A? So we'll start at vector B. So vector B, so this is vector B and this is vector A. So what will happen? What happened to the product? It goes to the opposite direction of vector C. Alright? Now if we have vector B cross vector A, then the product is negative vector C. Right? So if vector A cross vector B equals C, then vector C, since the product of two vectors is vector C, then vector B cross vector A equals negative of vector C. It goes to the opposite direction because the cross product of two vectors is anti-commutative. Okay? So we can use the right hand rule to determine the direction of the product. Right? So if this is vector A, this is vector B, then we have vector C. The angle is measured from A to B. Now, if this time, if the angle is measured from vector B to vector A, then the cross product is negative. This one. It goes to the opposite direction of vector C. Just as what we did to the scalar dot product, we can also give geometrical interpretation of the magnitude of vector product. Okay, suppose we have here two given vectors. The magnitude of the vector product of two vectors is defined as if there are two given vectors, vector A and vector B, the magnitude of the product vector is equivalent to the component of B perpendicular to the direction of vector A, or the component of vector A that is perpendicular to the direction of vector B. So here, this is the given vectors. These are the given vectors. You have vector A and vector B, and the tail of these two given vectors are at the same point, and the angle between them is phi. So what is the component of vector B that is perpendicular to the direction of vector A? That is B sine theta. Okay? If vector A cross vector B equals vector C, then the magnitude of vector C equals AB sine theta. So another way, the component of vector A that is perpendicular to the direction of vector B, and that component of vector A that is perpendicular to the direction of vector B is A sine theta, which is opposite to the direction angle between vector A and vector B. So again, if vector A cross vector B is vector C, and that vector C is perpendicular to both vector A and vector B, then the magnitude of vector C is AB sine theta. So what do you think the vector cross product of two parallel vectors? What is the angle between two parallel vectors? That is 0. So what is sine of 0? It's 0. So it means that the vector cross product of parallel vectors is 0. Now how about two anti-parallel vectors? Two anti-parallel vectors, it means if this is vector A, vector B goes to the opposite direction of vector A. So it forms a straight line, straight angle. And the angle between vector A and vector B is 180 degrees. And what is sine of 180 degrees? 0. So the cross product of two parallel and two anti-parallel vectors is 0. Now how about the vector cross product of two parallel perpendicular vectors. Suppose we have two vectors here, vector A and vector B, that are perpendicular to each other. If vector A cross vector B equals vector C, okay, then this is vector C that is perpendicular to vector A as well as vector B. Now what will be the magnitude? If the magnitude of vector A cross vector B is C, the magnitude of vector C, no? And it is C is defined as AB sine phi, where phi is the angle between vector A and vector B. So C is AB. Since these two vectors are perpendicular to each other, then AB sine 90 is what? Equal to 1. So if two vectors are perpendicular to each other, so it means the magnitude of the product vector is the product of components, so component of A and component of B. If and only if these two vectors are perpendicular to each other. So the vector product of two parallel or anti-parallel vectors is always 0. In particular, the vector product of any vector with itself is 0. So here is the two vectors, given vectors. A and B lie on the same plane, and vector C is the cross product of vector A and vector B. So vector C is perpendicular to the plane, also perpendicular to vector B and perpendicular to vector A. So the magnitude of vector cross product, which is C, is the product of the magnitude of A, magnitude of B, sine of the angle between vector A and vector B. Let us use components of given vectors to calculate the vector product. Okay? We know that the vector product of any vector with itself is 0 because they are parallel. And the anti-parallel, the negative of a given vector, the cross product of these two vectors, it must be 0 if they are anti-parallel or parallel. So it means the I hat cross I hat, the same direction, they are at the same direction, will be equal to 0, and j hat cross j hat is also equal to 0, and k hat cross k hat equals 0. So we're going to use the right hand rule coordinate system. We're not going to use the left hand coordinate system. The product of two vectors, the cross product of two vectors, is also a vector that is perpendicular to both the given vectors. So it means if vector I cross vector j, so we have vector k. Since vector k is perpendicular to both vector I and vector j. So I have here a right-handed coordinate system. So this is the x-axis, this is the z-axis, and this is the y-axis. The unit vector along x-axis is I hat, and the unit vector along y-axis is j hat, and the unit vector along z-axis is k hat. Alright? And we know that the product vector of two parallel and anti-parallel vectors is 0. Alright? So it means I hat cross I hat equals 0. Right? And then I hat cross j hat, right? J hat. So what unit vector that is perpendicular to both I and j? That is unit vector k. So it means vector I cross vector I hat cross j hat is k hat. Alright. How about I hat cross k hat? So we go at this direction, and we have negative j hat. That's negative j hat. And then what else? J hat cross I hat. Since I hat cross j hat is k hat, then j hat cross I hat should be negative k hat. Since the product of two vectors, the cross product of two vectors is anti-commutative. Next, about j hat cross j hat. Okay, these two unit vectors are pointing in the same direction, so they are parallel. Then the cross product of these two unit vectors is 0. Next, j hat cross k hat. So j hat cross k hat going at that direction, then we have equal to I hat. Okay, next, how about k hat cross I hat? Okay, k hat cross I hat going that direction, then the unit vector that is perpendicular to k and I is j. So we have j hat. How about k hat cross j hat? K hat cross j hat. Okay, since j hat cross k hat is negative j hat, this one, sorry, j hat cross k hat is I hat, then k hat cross j hat should be negative I hat, right? And then k hat cross k hat is equal to 0 since these two unit vectors are pointing in the same direction. So we have vector A cross vector B, right? Vector A cross vector B, there will be AX I hat plus AY J hat plus AZ K hat cross, okay, this is vector A cross vector B, and vector B is BX I hat plus BY J hat plus BZ K hat. Alright, so we'll use the distribution method. So AX I hat cross BX I hat. So we have AX to BX I hat, AX I hat cross, okay, BX I hat. Okay, then plus, so we're done with this, AX to BY, then that's AX I hat cross BY J hat. Okay, then next, plus AX to BZ. You have AX I hat cross BZ K hat. Right. Next, AY to BX. So you have plus AY J hat to BX I hat, to cross BX I hat plus AY to BY J hat. So you have AY, no, that's AY J hat cross BY J hat, then plus AY J hat cross AY to BZ, so that's cross BZ K hat. So plus, next is AZ to BX. So you have AZ K hat cross BX I hat, okay, plus AZ K hat cross AZ to BY J hat plus AZ to BZ AZ K hat cross bz k hat. So next, what is I hat cross I hat? Equals 0. So multiply this. This is multiplied by ax and bx, that is equal to 0. So we can cancel that one. How about I hat cross j hat? Where is I hat cross j hat? That is k hat. I hat cross j hat is k hat. So you have ax, bx, I hat cross j hat is k hat. Okay, next, done with this. How about I hat cross k hat? I hat cross k hat is j hat, negative j hat. So ax I hat cross bz k hat is plus ax. So since this is negative, so we have minus. So minus ax bz j hat. Okay, so we're done with this. How about this one? Ay j hat cross bx I hat. What is j cross I hat? J cross I hat is negative k hat. Right? So this is minus ay bx k hat. So we're done with this. How about ay j hat cross by j hat? They are parallel. J hat and j hat are parallel, so it means 0. The cross product is 0, so that is equal to 0. Next, ay j hat cross bz k hat. What is jy cross k? J hat cross k hat, that is I hat. So we have positive ay bz, j cross k is I, so we have I, it's positive. Okay, we're done with this. Next, az k hat cross bx I hat. What is k hat cross I hat? K hat cross I hat is j hat, right? K hat cross I hat is j hat. So this one is plus az bx j hat. So we're done with this. Next, k hat cross j hat. K hat cross j hat is negative I hat. So this one becomes minus az by I hat. And next, done with this. And next, this one, az k hat cross bz k hat. K hat and k hat are parallel, so we can cross that one since the cross product of parallel vectors is 0. And then we can arrange this. We can combine like terms here. This is y. Okay, so we can combine ax by k hat to ay bx k hat. We have ax by minus ay bx k hat. Right. Then plus for j hat, okay, so that's az bx minus this one ax bz j hat, right? Then plus for I hat, okay, I hat we have ay bz minus az by I hat. So we will arrange this by x, y, z components. Right, so vector A cross vector B equals, we'll start at I hat is ay bz minus az by, is by I hat, okay, plus for j or y component AZBX minus AXBZ J hat, then plus for K or Z component, that is AXBY minus AYBX K hat. So this is the cross product of vector A and vector B. So this is the cross product. Vector A cross vector B equals AYBZ minus AZBY I hat plus AZBX minus AXBZ J hat plus AXBY minus AYBX K hat. Okay. If vector C equals the cross product of vector A and vector B, then the components of vector C is AY, BZ, AZ, BY, right? And then CY as the Y component of vector C is AZ, BX minus AX, BZ, and the Z component of vector C is AX, BY minus AY, BX. AX, AY, AZ are components of vector A, and BX, BY, BZ are components of vector B. Okay, so this is the cross product of vectors using their components. So let us have an example of cross product of two vectors. Suppose these are the two given vectors. Vector A is 3i hat plus 2j hat minus 5k hat, and vector B is negative 2i hat plus 3j hat plus 4k hat. And then we will look for vector A cross vector B. Okay, and the product of these two vectors must be perpendicular to vector A and perpendicular to vector B. Okay, so what is vector A cross vector B? That is equal to AYBZ minus, since AYBZ it's easy to memorize. If I hat, if X component, what's next to X is Y, then we have AY, and next to Y is Z, then we have BZ, and then next you have minus, since this is AYBZ, then next is AZBY, then put I hat, plus, okay, for Y component, what's next to Y is Z, then we have the Z component of A, so AZ, what's next to Z is X, XYZ, XYZ, so next to Z is X, so we have BX, minus AX, BZ, then J hat, plus, okay, for the Z component, what's next to Z, that's X, so you have AX, next to X is Y, so we have BY, BY, minus AY, BX, K hat, right? So next, substitute. Let us substitute. What is AY? AY is 2. BZ is 4. Minus AZ is negative 5. BY is 3. Then I hat, plus AZ is negative 5. Then BX is 3, negative 2, negative 2. Minus AX is 3. Then BZ is 4. Then J hat, plus AX is 3. Then BY is 3. Minus AY is 2. Then BX is negative 2. K hat. So double check. AY is 2, BZ is 4, AZ is negative 5, BY is 3, AZ is negative 5, BX is negative 2, AX is 3, BZ is 4, AX is 3, yeah, then BY is 3, AY is 2, then BX is negative 2. Okay, let's compute. So this is 8 plus 15 I hat, then plus, what is negative 5 times negative 2, that's 10, minus 12 j hat, plus 3 times 3 is 9, minus, that's plus 4 k hat. 2 times negative 2 is negative 4 times negative, so negative positive 4. So next we have 23 I hat plus, okay, 10 minus 12 is negative 2, so this is minus 2 j hat, then plus 13 k hat. So this is vector A cross vector B. So this vector should be perpendicular to vector A and perpendicular to vector B. So let us check. So these are the two given vectors, vector A and vector B. The product is this one, but I named that as vector D. So as you can see, okay, this vector, the cross product vector of vector A and vector B is perpendicular, or it forms 90 degrees between angle vector B and this vector, the product vector, and also perpendicular to vector A and to this product vector. Okay, it forms 90 degree angle. So this is the cross product. So it's perpendicular to B, it forms 90 degrees to vector B. It also forms 90 degree angle to vector A. Alright. Okay, so let us have another example of cross product of two vectors. We have two given vectors here. We have vector C, which is 3i hat plus 2j hat minus 5k hat, and the other one is negative 2i hat plus 3j hat plus 4k hat. So we need to obtain the cross product of vector C and vector D, or vector C cross vector D. Alright, so since this is vector C cross vector D, then that will be equal to, we start at CY. So CY DC minus CZ DY I hat. Okay, so this is the x component of the product of vector C and vector D, plus CZ DX minus CX DZ J hat. This is the y component of the vector product of these two vectors, vector D and vector C and vector D. And then CX DY minus CY DX K hat. And this is the z component of the vector product of vector C and vector D. Alright, so let us start from CY. What is CY? Look at here. The y component of vector C, that is 2. And that is equal to 2 times what is DZ, which is 4, minus CZ, or the z component of vector C, which is negative 5. Then dy, we have 3. Then I hat plus, what is CZ? That is negative 5. So we have negative 5. Dx, the x component of vector D is negative 2. Then this is negative 2. minus cx, cx is 3, times dz, dz is 4, j hat plus, what is cx? That is 3, dy is also 3, minus cy, that is 2, and dx is negative 2, then k hat. Alright, so that will be equal to, what's 2 times 4? That is 8, minus, then since this is negative 15, then that's plus 15. Then don't forget to put the unit vector, plus negative 5 and negative 2, product is positive 10, then we have 3 times 4, then we have minus 12 j hat, then plus 3 times 3, which is 9, then negative times 2 times negative 2, that's 2 times negative 2 is negative 4, then negative, then we have plus 4 k hat. Okay, then we have 8 plus 15, that is 23, I hat, 10 minus 12 is negative 2, so minus 2 j hat, then 9 plus 4 is 13, so plus 13 k hat. So this is vector C cross vector D. So this vector 23 I hat minus 2 j hat plus 13 k hat should be perpendicular to both vector C and vector D. So this is the cross product of vector C and vector D. So let us see in the graph. So these are the two given vectors. This is how the two given vectors look like. We have vector C and vector D, and the cross product, I named that vector A. As you can see, the cross product of these two vectors, vector C and vector D, okay, the cross product, which is vector A, is perpendicular to vector D as well as vector C. So look at the case, it's 90-degree angle, and 90-degree angle formed by vector C and vector A. Again, vector A is the cross product of vector C and vector D, and also it forms 90-degree angle or right angle between vector D and this vector, the vector product. Okay, so that's the cross product of vector C and vector D, or vector C cross vector D, which is 23 I hat minus 2 j hat plus 13 k hat.